Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about data quality. This episode is based on a tech blog titled Data Quality at a Petabyte Scale, Building Trust in the Data Lifecycle, written by the engineering team at Glassdoor. You can find the link in this episode's description. Throughout this episode, we will explore this topic from both business and data science angles. Now let's dive in. On the business side, let's take a look at the problem to be solved. Glassdoor was founded in 2007, and now it is part of the Recruit holding, which is the same parent company that owns Indeed. It is one of the world's most popular platforms for job seekers and employees. Every month, over 50 million people would visit Glassdoor to browse job listings, read company reviews, and compare salaries, and get a feel of the workplace culture. What makes a company unique is that most of the information doesn't come from the companies themselves. It comes directly from the employees. People voluntarily sharing their experiences, salary details, interview tips, and opinions about their employers. This crowdsourced model makes the platform very rich in terms of insights, but it also brings a major challenge: the data quality. So what do we mean by data quality? Simply put, it's about how accurate and trustworthy the data is. And when that data powers the core product experience, keeping it clean and reliable is absolutely essential. Think about this. If the salary range is fully out of band, job listings are duplicated, or missing important context, the user experience would suffer. People may stop trusting the platform altogether. On the other side, it's not just about the users. Internal teams also rely on the same data to build dashboards, run experiments, and make product decisions. If the data is flawed, the decision will be too. In short, the poor data quality leads to bad calls and erodes trust, both externally and internally. And when you are dealing with millions of data points at a petabyte scale, manual fixes are just not feasible anymore. That's why Glassdoor's engineering team knew they had to act, and it is essential to build up a scalable, automated, and transparent systems for monitoring data quality. Now that we understood the business problem to solve, let's shift gear and dive into the technical side to see how the team tackled this challenge. At a high level, the team realized that reactive approaches to data quality were no longer enough. In the old setup, data quality issues were usually discovered by analysts or product teams after the data had already influenced dashboards or decisions. And by that point, it is often too late. Trust has already been compromised. So the team decides to make a culture shift from reactive to proactive approach. This shift required changes in mindset, process, and tooling. Now let's walk through how the team operationalized this idea. To support a proactive approach, the team introduced several key capabilities into their data pipeline. This includes data contracts, static code analysis, and even large language models, all together to detect and prevent issues before the data quality impact downstream systems. The first one, data contract. Think of data contracts as formal agreements between the team that produce the data, like the engineering team, and the team that consumes it, such as analysts, product managers, or marketing teams. These contracts clearly define things like expected schema, data types, required fields, and even backward compatibility rules. By building data contracts directly into development workflows, Glassdoor ensures that everyone agrees on what good data looks like. This creates accountability and helps prevent unexpected changes from upstream services that could break downstream dashboards or models. The second part of the component is static code analysis. But having data contracts is not enough. There also needs to be a way to enforce them continuously. That's where static code analysis comes in. Glassdoor integrates static code analysis into their development pipeline. That means every time a code changes are made, the system scans the code for violations of the data contract before those changes ever reach production. For example, if a front-end engineer removes a field that is required by downstream systems, say an employee ID field, the analysis can flag that early in the pull request. The issue is then caught, and the developer is notified, and then the fix happens before it causes real problems. This approach helps shift responsibility for data quality to the producers of data, not just the data engineering team. It also prevents costly incidents and increases trust across the pipeline. Followed by that is a business logic validation with LLMs. Now, even with the static code analysis in place, some issues are more subtle. For instance, let's say a developer accidentally swaps the first and last name fields. Technically, that doesn't break the schema. It passes the contract checks. But it introduces a significant business logic error. To catch these kinds of problems, Glassdoor fine-tuned a large language model to analyze changes in business logic and spot potential violations that the static code analysis might miss. This reduces their reliance on manual code reviews for edge cases and adds another layer of protection against the subtle but impactful data errors. Now, let's talk about what happens when a data quality issue is detected. The team classifies the checks into two categories: hard checks and soft checks. Hard checks act as a quality gates. They immediately stop the pipeline when something goes wrong. This is useful when the risk of pushing through bad data is too high. Soft checks, on the other hand, are more about visibility. They raise flags when something looks unusual, but they don't halt the pipeline. For example, if job seekers actively drop significantly during a public holiday, that might look alarming at first, but with the right context, it is understandable. A soft check flags it, but a longer look-back window helps analysts interpret the data before taking action. This dual system allows the team to respond appropriately based on the severity and the context of the anomaly observed. Besides setting up clear data contracts enforcing that, as well as handling the data issue with hard and soft checks, another interesting practice the team adopted is the concept of blue-green deployments, but applied to data. In traditional software development, blue-green deployment means maintaining two environments. One is a live environment called blue, and one is a staged environment called green. You deploy changes to green, test that thoroughly, and then switch traffic over when it is ready. The team applied the same idea to data. Incoming data flows into a staging environment when it can be audited and validated. Once everything checks out, it is published to the live production environment. This adds a controlled layer between raw data and the critical systems, and giving teams the chance to verify accuracy before promoting anything. To round out their proactive system, the team also built an anomaly detection platform based on statistical methods. In simple terms, this model helps to detect both global and local anomalies in time series data by factoring in seasonality and outliers. For example, it can distinguish between normal seasonal dips, like a quiet week in December, and truly unusual drops that might indicate a data pipeline failure. The team packed this into a platform where everyone can schedule anomaly detection jobs and receive email alerts with visual reports. This system even monitors infrastructure health, helping teams to spot potential reliability issues before they cause problems. Taken together, these tools and practices, the data contracts, code analysis, LLM-based validation, soft and hard checks, blue-green deployment, and anomaly detection, all of this forms a comprehensive approach to address data quality issue. Now we discussed both the business problem and technical solution. Let's wrap it up. In this episode, we explored how Glassdoor approached the challenge of ensuring data quality at a petabyte scale. They tackled this challenge by treating data as a product, building a centralized and scalable platform, and empowering the teams with tools to validate, monitor, and collaborate around the data quality. It's a great example of how technical infrastructure can drive organizational trust, and how data quality isn't just a technical issue but a cultural one. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I will see you next week.